Hey guys, I'm Jackson, this is Yoon Kong, and the topic of our project is Sarcastibot. So when I'm talking to people, I often find myself getting lost in conversations, and sometimes I don't know what the other person means, if they're actually being serious or they mean something opposite by being sarcastic. And to help people like me, we created a project called Sarcastibot, which its goal is to detect sarcasm by performing classification. But not only that, we wanted to, as a stretch goal, explain why a sentence may or may not be sarcastic. So for the data, we decided to use the Reddit Sarc dataset, which contains more than 1 million sarcastic and non-sarcastic examples. And we attempted to label it through 2 attempts. The first one, we wanted to label it through a multi-class label. There were many complexities and issues. I'll go over them later. And now we're labeling it with explanations, which give insights to why a sentence may or may not be sarcastic. We're labeling the data with GPT-4. So currently we have 2,000 explained examples labeled, and we split it in a 8 to 1 to 1 train, validation, and test set. The 2 numbers you see at the bottom are, we attempted to label 1,000 examples with the multi-class label I was talking about, with 706 turned out to be positive sentiment, negative situation, and 255 turned out to be negative sentiment, positive situation. As you can see, these 2 numbers do not add up to 1,000 because GPT-4 randomly threw in some of its own labels that we did not ask it to use. And also this data is very imbalanced in terms of these 2 labels. And we also want to utilize not only the classification ability, but also the text generation ability of LLMs. So we decided to use another approach, which is the explanation, which is also more generic. So if you want to know what an explanation means, here are some examples. So the first example is a data that's actually sarcastic. It says, glad to see they've upped their prices to deliver high quality advertising like this. The explanation that we got is it praises price increase, ironically pointing out bad quality, which is exactly what it's doing. And the second one is not sarcastic. It says, what about outside of that town, beyond Thunderdome? It explained that it's not sarcastic, but it also said that the tone could arguably hint sarcasm ambiguity depending on context, as the tone can be seen as skeptical or cynical. So we were really impressed by these explanations, as it not only points out the result, but also some underlying ambiguity.
Moving on to a more exciting bit, we approach this whole project as a class 1 project. So we have a baseline model and a main model. For the baseline model, we chose something rather simple, whereby we just use the glove embeddings to compute an average representation of the command before passing it through a linear classifier head to perform binary classification. And as for our main model, we decided to fine-tune Mistral 7B. It is a model that is quite similar to Llama 2 7B, except that it performs a lot better across a whole suite of benchmarks. And to use Mistral 7B, we used it as a text generator in a Q&A kind of style. And specifically, we actually fine-tuned the non-instruction tuned model. So it was the original pre-trained version of Mistral 7B. And in order to do that, we actually quantized the model and also trained it using LoRa to reduce the number of trainable parameters and therefore be able to train it locally. And with that, we are able to achieve a validation accuracy of about 83.8%, and this is based on the labels that the model output in text form. And for reference, if we were to look at the baseline model that we have trained, it managed to achieve about 57.8%. And if we were to train Mistral 7B by replacing the model head with a linear classification head, similar to how the baseline is done, we get an accuracy of close to about 70%. And if we were to do it the Q&A style, we get a substantial increase to about 83.8%. So looking at some of the generator output, do note that the output here is not the raw output from the model, rather we formatted a little bit so that it's easier to see here. And what we realize is that the fine-tuned model is very sensitive to picking up the very vague keywords. So sometimes the command might have very vague references, and the model is able to extract the entire context, infer the entire context, and this context is largely drawn from the pre-training process, the knowledge that it gathered during the pre-training process. So, but then one problem that we observe, it's not very common, but occasionally there will be some hallucination problems, as with all large language models. And this kind of hallucination manifests in the form whereby the model will make reference to a conversation that we did not actually provide. So one hypothesis may be that the model has seen all this conversation before, that's why it's doing this, but then most likely this is just hallucination. And another thing is with regards to handling ambiguity. So in this case, like if you look at the non-sarcastic example on the right, we do see that the model is able to handle a certain degree of ambiguity. And in future, if we were to be able to redo this project again, some of the things that we might have done differently might be that we will not give GPT-4 like the class label when trying to generate an explanation. We might just make it do the exact same task as during our fine-tuning process, whereby we just give it the command and it's supposed to generate an explanation along with the class label. So that will allow us to have a direct comparison between our fine-tuned model and GPT-4. But that will also require like much more effort in terms of the prompt engineering process in order to extract the best performance out of GPT-4 in order to establish a fair comparison. But then this also brings out the point whereby GPT, like fine-tuning a model ourselves instead of doing prompt engineering, it's also a very feasible way to do this to avoid like the nasty headaches that comes along with prompt engineering. Thank you.